Hello viewers, it's Previous the Tutor. I have a question on more concept. Let's work it out together. The question says 2 grams of calcium carbonate decomposes as shown. So calcium carbonate here decomposes to form calcium oxide and carbon dioxide. Calculate the moles of calcium carbonate, also the mass of calcium oxide formed. So to do this, let's go. So first of all, for us to find the number of moles of calcium carbonate, we need to know the relative molecular mass of what? Calcium carbonate. So let us first find the relative molecular mass of calcium carbonate. And how do we do that? We do this. So this is 3 multiplied by mass number of oxygen is 16. This gives us 48. 1 carbon atom, mass number of carbon is 12, which gives us 12. 1 calcium, mass number is 40, this gives us 40. Then we add everything here, we end up getting what? 100. So 100 is the relative molecular mass. I would put it like gram per mole. Let's say we're equating the molar mass. So that's the molar mass for calcium carbonate. And how do we find the number of moles? So number of moles is equal to the mass given over the molar mass. Over molar mass. We found 100 here, so I'm going to erase this part. So the number of moles, in this case, the mass given is 2 grams. The molar mass, it was 100 grams per mole. So this gram and that gram will go, and more. So let's divide 2, we divide by 100, give us 0.02 moles. So these are the number of moles of calcium carbonate. Is it clear? Then we can look at question 2. Part 2, which says the mass of calcium oxide formed. So what's the mass of calcium oxide formed here? How do we know the mass of calcium oxide? There are 2 methods we can do that. And I'm going to show you both of the methods. So let's say method 1 here. Method 1, we are going to use the mass ratio. Method 1, we use the mass ratio. So we are going to compare the masses of calcium carbonate to the mass of calcium oxide. There's 2 grams of calcium carbonate given, but we don't know the mass given for calcium oxide. That's what we're looking for. But at the same time, there was 100 grams of what? Grams per mole of calcium carbonate as molar mass. But do we know the molar mass for calcium oxide? Actually, we can do that. We can find it. So calcium oxide is like that. So we have 1 times 16 and 1 times 40. And when we add this, we are getting 56. So we are going to put 56 here. Then we cross what? Multiply. So crossing multiply gives us x is equal to 2 multiplied by 56. We divide by what? 100. So the mass, so our 2 multiplied by 56, then we divide that by 100. It's giving us 1.12. So 1.12 grams of calcium oxide. This is the first method. The method number 2, we are going to keep our mass there, our molar mass. That was method 1. Method 2 is what we call mole ratio. Mole ratio. We are going to compare the moles of calcium carbonate to the moles, all right, of calcium oxide. In the equation, there is 1 here and there is 1 there. So it's 1 to 1. The number of moles for calcium carbonate, which we calculated here, it was 0.02. So we put 0.02. Here we put what? X. So now, remember, because the ratio is 1 to 1, whatever I multiply to be just the same. That means even X, which is the number of moles for calcium oxide, is just 0.02 moles. Now, remember the question is asking us to find the mass, right? So mass is equal to number of moles times the molar mass. From the same formula that we used here, we said mass, we're just making the substitute. The formula is mass there. So the number of moles is 0.02 multiplied by the mixed, which is the molar mass, is 56. So I said 0.02 we multiply by 56 is giving you 1.12. The mass is equal to 1.12 grams for calcium oxide. You can see that this is what we found also at first. So thank you for following me in this video. I hope you join our online classes. It will be better. We are here to beg you, to teach you proper so that you can make it in your GCE and G12 exams.